and I did it again.
Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Welcome to Troubleshooting, our program with the moon at noon. Hey, everybody. Today it is yet again noon on a Thursday, which means that we're going to be doing the moon at noon, and we are going to be doing a troubleshooting episode this time. So the timing of the sky at the moment is not great. The moon is coming up after sunset for the next 2 weeks, which is not great for those of us who like to sleep. And so, which few and far between in the astronomy community. And so we're going to take this episode to just talk a little bit about some of the problems that we've had when we've been observing, and all sorts of stuff like that. So those of you who don't know us, I'm Jenna. I'm a Rask person.
I'm John. I just like the moon.
Samantha, I'm just here to learn.
Oh man. All right. So I'm going to start us off with a poll to see how many of you have been out observing so far in this program. I know a few people are still joining, and as they join, hopefully they can vote. But if not, you all who are here in the Zoom chat can join, can vote first. So we're going to ask you, how many of you have been out observing so far to see the moon? And while you answer that, I'm going to promote our local question answerer, Dave Chapman. He's going to be joining us for our show today, because he developed the program, and so he'll be helping us answer some of these questions as we go along.
I actually saw the moon this morning, so I could now answer your other poll that you were planning to do, which was what percentage of people go out and observe the moon in the morning?
That's true. We were going to ask that.
Hi, Dave.
Hi, Dave.
Hi.
Special guest today.
Special guest.
They have a moon mug.
No, it's a handbook mug.
Oh, okay.
It's got a facsimile of the first handbook in 1908 on the mug.
Very nice.
Wow.
It looks like it has like a moon texture.
Pat Kelly made this for me.
Wow.
On the occasion of the 100th anniversary of the handbook, and well, he didn't just make it for me, but he gave me one, and he had the 2008 and the 1908 covers on the. So I made my tea in it today.
Lovely. I'm going to wrap up our poll, and the answers are somewhat as I expected, and we'll share the results with you. Which most people have been out a couple times. A few people have been out a lot. Nobody is saying that they are not ever going out, which is good, because that's the whole point of this program. So I'm glad that there's no one here who's holding a grudge against observing.
Wayne said that they got all the targets so far.
Wow, Wayne.
Been able to view.
That's awesome.
Wayne's pretty much an ace observer down in Liverpool, Nova Scotia. He's out a lot.
Oh, wonderful.
Taking a few photos, Brian.
Nice. So that's awesome. Good for all of you. And this is one of these really interesting things about this program, is that if you are super ambitious and you get it down quickly, you can finish the program in like a single lunar cycle, and if the weather's good. And so we'll be talking a little bit about that today as we go along too, because we've all been observing and have noticed a few things. Mm-hmm. I'm going to kick this off with, I observed as well, and I'm really excited about it. And I got angry at John today because as I was outside and observing and writing down my observations, I was looking at the maps in this book and going, that's not right. I'm sure something's wrong here. This isn't the view that I have, and there's only two views, and this is the view that's supposed to be from my telescope, and how come it's not right? And John was like, were you tilting your head? And I was. So So my bad. I just sat here. I went out and observed. This is mostly Q day 1, which we haven't gone over, or Q day 3, I think, which we haven't gone over yet. But I went out and observed Copernicus, Reinhold, and another one.
Landsberg?
Yeah, Landsberg. And they made this little curve like this. And the only way I managed to figure out that John was right is by looking at the curve in this picture and noticing that it did the same thing. But it was like this.
I had to figure it out because I was like looking at it and I just was drawing it at the angle I was looking at it. So when I put it right side up, I'm like, everything's this way.
Yeah.
Well, a lot of it. So I make a lot of my own star maps for the books and stuff. And depending on what orientation you are, east to west has an effect on, when you move up to the sky, what angle your map is positioned at as well. And then also a lot of people that use Newtonian telescopes or tabletops will look from the side. So that might give you a 45-degree rotation, or you might be on the other side of your telescope, depending on the design, and that might rotate your view a little bit the other way as well. And even like you're using a Smith-Cassegrain design telescope, and especially if it's low, and the tripod's not all the way up, you also might be looking at the moon, a little sideways with that. So that was my first clue.
I think my best advice is we've given you these maps, but and Jenna will go more into this a little bit later about how the moon changes, but just rotate them. Fine. Just because one's named reflector, refractor, binocular doesn't mean you have to use the one that matches your telescope. I find the binocular view for me is easier to find on my telescope, even though I have a Newtonian reflector. And just move it, and whatever helps you find your targets, because that's the point, is to see what's up there.
If your brain can handle doing the flipping itself instead of having it flipped on a piece of paper, awesome. Mine can't. Samantha's can.
Yeah, what about you?
Dave, can you mentally flip images of the moon?
I guess I've been doing this a long time, so I like to use the map that matches the view. But if I have to, I can flip it in my head. The problem is, especially for beginners, I think when you're looking at things that are basically round, when you flip them, they're still round. So the shape of the things don't often give you a clue. You have to look at the patterns of things, like the triangles and squares. So you have to be, if you're good at pattern recognition, then you'll be good at lunar observing, because it's all about recognizing patterns, I think.
It's a really good skill, because when you move to sort of explore the universe stuff where you're using star maps, we don't tend to flip star maps at all for mirror reversed views, and or very rarely anyway, or or finder scope views or anything like that. So I guess, Samantha, your skill will definitely transfer.
I think it's all my knitting and memorizing patterns,
Maybe. A lot of the apps, like Sky Safari, Stellarium, have ways that you can flip the view on the screen. Many people don't know about those, but I use when I use my phone to use Sky Safari, I will actually flip the view to match what I'm seeing, and I find that helpful. The other trick is, if you have a stationary telescope, not tracking, if you just watch the moon drift out of the view, everything in your telescope always drifts celestial west. So that gives you one of the directions right there. Just let it drift, and that's west. Whatever disappears first is west. And it doesn't matter if it's the moon or a star or what kind of telescope or wherever you are in the world. That's the truth. So that's a good thing to remember.
On that note, though, while you say everything does drift celestial west, and
celestial west.
Yeah, that's the thing. So I'm what, 28, and I still do the rises in the east, sets in the west when I'm trying to figure out which way things go. But I want to just jump over to a view in Stellarium real quick, because if you're observing the moon and it's close to the horizon, celestial west is up.
Yes.
Or slightly different direction. So that's
correct.
Yeah. So this is the moon tonight at 1 a.m., which is obviously fairly late. And you can see that in this case, if you connect the round edges to the side that is not round. In this case, it works better with a crescent, but we can do it here. This is about the angle of the moon compared to the horizon, which is straight across. So it's at an angle. And where, if you follow it for the rest of the night, it seems to rotate.
Yes.
So that's another trick, is that all moon maps mostly show you the view like this when it's right in the middle of the sky, when it's straight up and down.
You have to choose one.
Yeah, and that's a good one to choose. Yeah. And then, of course, if you're in Australia, everything is all backwards and upside down. So we're not.
I think others have said this before, and it may sound confusing at first, but once you get out there and do it a bunch of times, it all kind of starts making sense. And then after a while, you don't have to think about it. Mm-hmm. But yeah, it can be confusing.
Mm-hmm. It does take a little bit of practice. And yes, Pedro, we will get to your question about the Taurus Mountains, but when we're talking about celestial west, and I'm going to actually jump back to stellarium again, celestial west is like west if you're looking at the directions as you're standing on Earth. So west in this case would be over here. But on the moon, it's like we're looking at a map. So you're right, it's east on the moon. So this is north here, south here, west over here, and east over here. You're right, that part is also confusing. Okay. Dave's right, practice. It makes a lot of it. And that sort of being lunar aware and like aware of what's going on in the universe around you from night to night is really helpful too. Just keeping an eye on how things move and where the moon goes is really helpful.
Just as an aside, if you use my rule for finding celestial west in your telescope view, if you learn how to do that, that'll hold you in good stead if and when you try the double star program that the RESC has, because it's always good to orient yourself when you're doing double stars. So the first thing I do is to center the star and then just see where it drifts. And then I put a little mark on my sketch, I've got a circle and I say, this way is west, right? And so that'll help you when you're observing other things in the sky.
Mm-hmm. I know that we have, Samantha's about to sneeze. I know that we have a few questions about things like observing in the morning as well, and what the moon looks like during the second half of its cycle when it's waning and it's going from bigger to smaller. So after the full moon and onto the new moon. So I'm going to share in stellarium. Hey, there you go. Yeah. And so I'm going to share again the view in stellarium and just show over a couple of days how the sky changes a little bit. We're going to get into this more next episode, because next episode we're covering lunar days that happen when you can see the moon in the morning. And so we'll dive into that a little bit more. If anyone wants to help narrate on this too, I'm not strong on this sort of like area. So this is tonight, and tonight the moon's rising around midnight. This is tonight in Toronto, for those anywhere else in the world. And as we go through the night, the moon comes up and then it starts to set again. But because it is waning, it's going to be visible in the sky in the morning for a little bit after the sun has come up. Same way that when it's waxing, it's visible in the evening. And so if you're the kind of person who gets up at 6:30 in the morning,
Not me.
not me.
Voluntarily gets up at 6.
Yes, that's true.
Yeah.
And I mean, you can be opportunist about this. If you have a child who wakes you up at 6:30 in the morning, you might as well go observe the moon, or a cat in some cases. So here we have what the view will look like this morning at 7:15, or sorry, tomorrow morning at 7:15. The moon is still up in the sky, and it will still be up until another hour after that or so. And this at the same time as the sun. So there's the sun up on the other side of the sky.
Question about that. Like, is it safe to view a moon when it's in the sky at the same time as the sun? Because like I was seeing the moon outside at like 5 p.m. and I was like, is it even safe to do it then?
I mean, it's generally more than 90 degrees separation from the sun. So it's the probability of your telescope actually slipping to the complete other side of the sky, it's pretty low. When the moon is close to the sun in the sky, it's generally almost invisible, like during the crescent phases. Mm-hmm. It's generally almost invisible during the day. And it doesn't start to appear till you near first quarter, and then you can see it while the sun is still up.
Mhm.
So you always have this, quite a bit of sky between the moon and the sun where you're pointing your telescope. The other thing you can do, and this is what I generally do, especially with kids, is you set the telescope up in a place where you are in the shade from the sun, but can see the moon. And then there's zero chance that the telescope could go and accidentally point over toward the sun.
That's a very good point. On that note, in terms of the angles of separation that we're talking about, I'm going to scoot us ahead in time until we're at, so that we can show where these two, the sun and the moon, are positioned compared to each other over time. Bearing in mind that we're really zoomed out at the moment. So these are more or less on opposite sides of the sky, but we're zoomed out, so they look like they're in the same field. If we had gone back a couple days and a little bit earlier when the sun's just rising, you'll see that at the full moon, the moon is on the exact opposite side of us from the sun. So if this is Earth and this is the sun, the moon's over here. Yeah, I'm doing great. And then as it comes along, I'm going to use this as our axis. So we'd be looking down on the Earth. So you're looking down on the system. As the moon goes around the Earth, at quarter moon, it's here. So this half of the moon is lit up. This half is not. And we see it half full. And that means it's 90 degrees away from the sun. And that's what, let's say, around here would be, where the moon is going to be up for half the day and up for half the night. And that would be at one of the quarter moons. And so for a quarter moon, this is going to be May 3rd. So that's Monday. As you go through the day, the moon's going to be up longer than it was earlier in the cycle throughout the day. So you can go out in theory and observe it at 10 in the morning. Well away from the sun, it'll be pretty dim. It'll be quite slanted, but it will be there.
That's more like my time I wake up.
That's the good stuff.
Okay, I wake up slightly earlier than that. I'm not that bad, but
Does that all make sense?
Well, I guess I have a question there. You lose, I understand you lose some contrast when you're viewing the moon in the day. And so some of the craters that are less pronounced, like Cook and Newcomb, for example, they might be more challenging to see during the day. So I guess question for Dave, would the moon filter or other type of filter or strategy, maybe a magnification strategy, help improve contrast in viewing the moon during the day so that you can see some of these more challenging targets?
I was going to say no, but after thinking about it, the light that gets scattered in the sky is polarized.
Right.
Whereas the light coming from the moon is not. So you can, if you use a polarizing filter and rotated it, you might be able to improve the contrast. Because when light comes in from the sun and gets scattered to you, it's a bit complicated, but the light that's scattered, like the blue light of the sky, is polarized. The people and photographers use that when they want to get contrast between the clouds and the sky. They'll put a filter on and they'll rotate it. If you have a polarizing filter, it might help.
Can you ever use two polarizing filters to do it? Because then you could adjust.
That would just cut down the intensity overall. I'm not sure that would be very helpful.
Because then you can sort of rotate them like that to control your brightness.
But a regular moon filter probably wouldn't help you. It would just make everything dimmer. Yeah. But if you observe not in the middle of the day, but just as the sun is coming up or a little after dawn, or the view is quite nice because the sky is like a darker blue and there's not so much scattered light. I confess that I am a morning noon observer, but I also confess that I only started doing it after I retired and I didn't have to go to work. So I was doing Isabel Williamson like about 10 years ago, and I would plan my observing the day before. And I would get up at 5 o'clock in the morning and go out and observe, and I'd be all ready and I'd do my observing. And it's actually a lovely time of day to be outside. But then I would come in and I would crash. Like I would, I'd get my observing done and I would sleep. I would sleep a few hours in the morning. So not everybody has the luxury of doing that. But if you do have that luxury, you can get finished twice as fast if you think about it.
Mm.
And I was doing Isabel Williamson, which is like hundreds of things, and I wanted to get her done. And so I realized, oh yeah, I should be doing this in the morning. And particularly like coming up May the 3rd, it's the last quarter. You don't have to get up super early, but I think it's really cool to look at the last quarter moon and especially, and maybe even the day later, because you get to see the straight wall illuminated from the other side. And I always think that's really cool to see it, because when you see it at first quarter or after first quarter, it's kind of a dark shadow. But when you look at it at last quarter, it's a bright light. It's a line because the face of the cliff is being illuminated. And I always encourage people to try that. It's fun.
Okay, so as you've mentioned that, I've gone and grabbed the photo of what it's going to look like on May 3rd. Remember, as far as I know, this is not a target for Explore the Moon, right?
No,
Straight wall is. Yeah, it
Straight
is.
range isn't.
Straight.
No, I think they
straight
both
range
are.
is.
I think they both are. Straight
Oh, yeah,
wall
they
is.
both.
We had that discussion last week. It is.
Yeah, that was my bad.
You can see it there in the picture really good. You see it there?
Yeah, there's that light streak, eh?
And it's got this like little bright light. Yeah, that's cool. Right next to Bert. Yeah.
That Bert?
Yep,
Yeah.
that's what-
BIRT. Bert.
For the straight range is what we talked about last week, and that was the
Yes.
Q day that we were observing last week. And
Yeah.
so, yeah, there it is. And the straight wall is what somebody else was asking about last week.
Yes.
So, if you fancy an early morning and it's nice, I mean, you could look at all those lovely craters you can see in the morning, next Monday morning.
And and that was the day that we were looking at in Stellarium, where it's up until like well into the morning, around 10 a.m. So
Earlier the
maybe you
better.
can see straight wall
But,
as well.
if people get up and walk their dogs, they can do that.
Yeah,
Exciting thing to do on a Monday morning.
for sure. And now a reminder as well for anyone who's watching to toss your questions in the Q&A because we only have a few minutes left. And there's a question from Pedro, which was, any trouble finding the Taurus Mountains? I haven't found them yet. So I can't answer that. It's very possible I would have trouble. And for a reminder, the Taurus Mountains are a Q day -3 object under Hercules and Atlas.
I think I skipped those too, because I was using a very small telescope at the time. So
Yeah,
I
and
haven't seen them either.
It's a bigger area than just is covered by that smudge. So it's almost the size of the word mountains there. If you were to pivot the word mountains in a circle,
It's this area that's
all of
big.
that area, yeah.
Okay.
And so it's between that. I guess that's Sea Serenity and then Mare Caricium. There, it's most of it. It's it covers almost half that area. So it's not a small target.
Yeah, they're like if you look at the Mare Serenitatis, hold it. Which one are we at? Which one is? I should know, right?
You wrote the book on it.
Apparently.
The Taurus Mountains are the ones where Newcomb sits, right?
Is that are they listed as Y? Y. And that's their label with the
I
Taurus
apologize
Mountains.
if the map didn't do the whole thing. It was actually quite difficult because the mountains are hard to contain. They're not as easily as to say, oh yeah, this is the one crater.
Yeah.
So
I
there's
think though,
Newcomb.
I think what makes it difficult is many of the mountain ranges are essentially at the edges of Mare, and they're very linear and curved, and they stand out. I think Taurus Mountains are more like a blob of mountains, and that's why I think people don't recognize them straight up. It's like a bunch of mountains with a bunch of craters amongst them.
Mhm.
So whereas the other mountain ranges, like they show very prominent linear features.
Mhm.
And so,
There was this mountain range, which we had for our observing night the other day for Q day 2.
Jura,
What's that?
Jura.
Jura Mountains. Yeah, and I lied because we didn't actually have that. That's a separate Q day, but it's around Sinus Iridum. Those are really obvious because Sinus Iridum takes up the space in front of them.
Well, it's like a basin. It's like a flooded crater. You see.
Mhm.
And so it's really what it is. It's the wall of an ancient crater that's been flooded. That's what a lot of those seas are. But yeah, Taurus
the
are a bit
bottom.
obscure. It's very busy up there, so you can easily get lost.
I find I get lost at the bottom too. And John, I know you have the tip with Clavius, and that did help somewhat. The only one I could find, I went out observing on Q day 2 and I could not find the Q day 2 craters, but I did find Schiller, because the description was long and elongated. And in the notes I've written, indeed, long and elongated, because that was exactly what it was.
Yeah, that one's the one I called the pickle.
That's a good one. I like that.
But Samantha, I think it does help if you can increase the magnification a little. Some things are quite obvious at low magnification, but I think I've advised a couple of people, like John found he had to, with his small telescope, he had to include his Barlow. I think you should be looking at it like 60 power to 100 power is not a bad power. You don't have to go super high.
Yeah, I did the whole thing at 50.
Yeah.
But I think but that's because I wanted to challenge myself, because I figured that's what most people would be doing.
Yeah.
But yeah, I mean, as you go higher, the moon drifts faster.
Yeah.
And if you're sketching, that's really annoying.
I think I'm working with a small telescope too on purpose. I've got a big telescope, but I'm using my 70 millimeter Ranger, and I'm working at around 70 power, 75 power for everything, because I wanted to. I mean, I designed the program with friends, but I realized that I actually had never completed it as an observation challenge. So I said, well, I should do this, and I should do it as if, I just had this small telescope and not something fancy. And so I'm on purpose doing it that way to see what the challenges might be for someone with a small telescope.
I've been hopping back and forth between a Cometron first scope that is really tiny. It's one of those scopes that the eyepieces are more expensive than the scope itself. So I had a Barlow and a 20 millimeter. And then I have a reflector that's 114 millimeter. I don't know the power. So I just got lazy that one night, and I didn't want to pull out the big heavy one.
Don't get me started about those Cometron first scopes. You don't
What?
want to hear.
It took a month for us. We bought it, and a month later we moved up to a bigger scope. So
Which I guess why, so I started with a tabletop very briefly in my first session, and then switched up to refractor. But are you still going back to the Cometron on purpose, or are there benefits to that?
The reason why I'm wondering if other people might have this, is the night I took the first scope out, it was 11 p.m. I was in my pajamas ready to go to bed, and I saw a clear sky. And it's one scope is a little bit heavier and harder to set up, but because it's an equatorial mount versus the first scope's a Dobsonian. So I just wanted to get something out and get some observations in. So that was kind of my way to be able to go out for 15-20 minutes and see something without making it too much effort, as I'm standing outside in my front yard with my pajamas and all the dog walkers are looking at me. But yeah, the other 2 times I've gone out, I've taken the bigger telescope out, because it's been more planned and more time to do it. So
I go to parties on my street when we used to have parties, and I'd be sitting around talking to people, and they go, "Hey, you're the telescope guy." Their kids come home from being outside. They say, "Yeah, there was this guy with a telescope, and we looked at the moon." And then I meet people at parties. "You're the telescope guy," because I do that all the time. I say, "Hey, have a look at the moon."
It's always worth it. It's hard these days not being able to do that.
Oh yeah.
I see Jill has a question in the chat about Helivis. Tried Q6, but moon was already too full. Or is Helivis just
Hevelius?
Hevelius. Oh.
Yeah, you just have to wait.
So I haven't tried to observe on Q day 6 yet. So I'm going to bring up Samantha's picture of what Q day 6 looks like. It looks like it's a very narrow window to observe it in. Dave, do you have any tips on observing Hevelius?
Can you show me the picture again?
Yes, sorry. I'm going to try to remember that date, May 25th.
Yeah, well, I guess the tip is find Grimaldi first, because it really burns out. I mean, Grimaldi is one of the binocular targets, because it's a large crater with a dark floor, and you should be able to find that fairly quickly. And then it's just a question of looking at the one next to it. So
Yeah, because technically right now, if you got up at midnight or whenever moonrise is, and like it's still there, it's not in shadow.
It,
So if you had enough contrast,
you can see it on that picture. I can see it. There it is right
Yeah.
there. Whoop.
Mhm.
Yeah.
I'm gonna bring it up in
Um,
more detail.
but it is, it is the one that I seem to remember this one getting washed out for me as well.
It looks like it's easy to wash out.
Yeah.
Yeah.
So,
Brian?
see it look for it like a day or so before full moon. I guess that's what Q day 6 is. But you can still look for it on the full moon, because even though it's fully illuminated, you have to remember we're looking at a sphere, right? So it's actually at an angle, so that the sunlight's still coming in at an angle. So it's not overhead illuminated. There's still a bit of shadow on that there. So it's very narrow because it's foreshortened, because it's on the edge of the sphere. So
Mhm.
you should be
Yeah.
able to see it at full moon, and you might even be able to see it tonight if you went out late enough.
I mean, there's definitely libration. It never gets covered up by libration on
No.
the map, but there's definitely certain months would be others in terms of like how far away it is from the limb. So
So
libration is an apparent rocking of the moon back and forth. And so sometimes you see more on these sides than other months.
Mhm. I will also mention that when looking at this stuff, so for example, in this case, I looked for the full moon day, which is at 7:14 a.m. The night before is pretty darn close to the full moon. And so you might want to find a day when the full moon is at like in the evening and go out the day before instead. Because the Q days don't line up, like
Yeah.
the moon's fullness does not care about what time it is on Earth. And so if it's full at 7:14 in the morning, it's going to be more full on Q day 6 this time around than if you had a full moon that was at 11:30 at night. So that's almost a Q day 5 the day before, because it's so late in the evening on the full moon day.
Yeah, those are really just planning aids. The Q days, like people have asked me about that. Like we don't even ask you to write it down when you make the observation. They're really there for planning, just so that. But they're not hard and fast. You can kind of go back and forth by about a day each way. So just try for it and see.
I observed -3, technically Q day -3 and -2 on the exact same day, and did all of them.
Yeah.
Also about, I'm going to say this wrong again.
Hevelius.
Hevelius. Brian said they looked for the double crater behind Grimaldi, and that's how they found it.
Hold on, I'm
Yep.
gonna go back to that photo. The double crater behind or beside?
Beside.
Okay. Let's go zoom in on that photo. I'll share my screen instead of just me having the privilege of looking at it. We'll do this as our last thing, and then we'll wrap up. So the double crater beside. Do you mean both of these? That may be what they mean.
Yeah, that might be
Yeah.
what they're talking about.
Well,
Yep, that's what they're talking
That's
about.
it. Perfect. Cool. Awesome. Well, I thank you all for bringing your questions. Thanks, Dave, for joining us to answer all of these questions.
I'm glad to be here.
We are thankful to you for making.
I'd
this
rather
program.
I wouldn't want to be anywhere else right now.
Mhm.
Thanks for inviting me.
Lovely to see you all again, and we will see you next week at the same time, same place. We're going to be talking about Q day something else. I've already forgotten.
Go out and observe though, if you can.
Yeah, try a morning observation just to see what it's like. Or in fact, for your homework this week, if you're looking for some specific homework, just pay attention to where the moon is at which times of the day. Look for it in the morning, look for it in the evening. One of those will be successful.
Yeah, well, John and I aren't going anywhere, right, John?
We are in lockdown
I mean,
mode.
Stay
We're
the
in
blazes
Ontario,
home.
so
Welcome to the lockdown.
we live in lockdown.
I could actually go and see John. I think if I stood out on the street in front of his house, I could talk to him. But
There's
Yeah.
always those kinds of options.
Well, we're a family of 5, so no one's allowed over because there's a
No.
5-person gathering limit.
yeah, we had to cancel our family dinner there. I mean, we're happy to comply to fix this thing. We're
Yeah.
not complaining, but it
Yeah.
is, it is getting old.
Yeah.
Yeah, because we had almost 4 dozen cases today. So hopefully, in a week we can get that down to 0.
The
But
daily
thank-
numbers
Okay,
are going
okay, we're
down.
not
Thank
talking about
goodness
COVID, guys. Stop
Thank
it.
God-
Stop
Sorry,
goodness
okay,
astrology
sorry.
is a
Stop,
solar
no.
thing, so you don't have to have people to go view the stars or go
Don't
out.
share
so.
eyepieces.
Yeah, don't share eyepieces. Observe on your own.
All right, we'll see you all